Good morning, everyone. My name is Annie Fink, and I'm the Marketing Coordinator for Wonderware, California. Thank you for attending our webinar today focused on simple tools to keep engineering design on time and on budget. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or you can email us at webinar@california.wonderware.com. Now I'd like to introduce your presenter for today's webinar, Ian Piggott. Ian is a Senior Technical Sales Consultant at AVEVA. Good morning, Ian.
Hi, Annie. Well, good morning, everybody. Today what we're going to do is we're going to do a presentation on the AVEVA Engineering design tools. This is just part of our portfolio. What we're going to cover is we'll talk about our integrated engineering design solution. We'll talk about the applications that make up that engineering design solution. And then what we're going to do is we're going to present a live demonstration of the software. We are not going to go into detail in any specific product. The purpose of the presentation today is to show you how change is managed across all disciplines from the concept of when it's first created and then consumed by the respective disciplines. And you'll see how when we get into the presentation, how that's managed and controlled by the software. So what we've got is we've got the aspect of the digital twin. So in our particular case, we're creating parts of the digital asset. So we're going to be touching on these areas down here around conceptual process and plant design. But we do have all the other applications for engineering, procurement and construction. And then we interface with the operations side of the facility so that anything that's required to be able to access data can be accessed data. So that gives us what you want on the digital twin there. So where are we? This is where we're going to be focusing today, is around the unified engineering. So it's our 1D, 2D and 3D. So basically the 1D is lists, things like equipment lists, valves lists, instrument lists, and how all that data is managed and then goes on to be sort of further engineered by the respective disciplines. The 2D side is the P&ID, the flow sheet, and then what we're going to do is we're going to use all that data that we've created to come through and basically use that in the 3D model to create a line and explain how the P&ID data is developed from the 1D data and how that progresses into the 3D model. So the AVEVA P&ID application uses AutoCAD as its canvas, so it's very easy to use and adopt. The basic concept is it reduces errors and rework in the simple fact that there's a logic behind the diagram. So if you go in and you change a reducer size, it knows that everything downstream of that reducer has basically got to change size as well. It's got the concept of loops for instruments. So if you change an instrument loop name or you add an instrument to the loop, all that can then be identified through to the process controls discipline. And because it's sitting on this particular canvas, it's flexible and it's configurable. AVEVA Engineering, it's basically where the process mechanical people will work, entering their data, doing their calculations and things like that. From that, they'll be able to create the mechanical and process data sheets. You'll see how, or I'll explain how we go through it, how the disciplines manage the data. But basically on an object, an example would be a pump, is there would be attributes for process, there would be attributes for mechanical, and there would be attributes for electrical. Basically, the way the software works, it will control what discipline can change what attributes. So the process discipline can't change mechanical, and mechanical can't change process. So what we've got is we've got full control over who can change what within the database. The thing to be very cognizant of here is this is a data-centric system. So what I mean by data-centric is the data's only ever entered once. We do not transpose data between documents and drawings. That data is read by every single document on the project and drawings. So if I've got a pressure that I put in for a pump, the mechanical data sheet reads that, the process data sheet reads that. If I need to show that pressure on the P&ID, the P&ID reads that. So what we've got is we've got one source being read all the time so that we can be confident that the values being shown on the respective deliverables are always the same. We can create lists, so you basic equipment list and line list, and you'll see that as we go through that. But another nice thing is what we can do is, because we manage change, we can do highlighting between different versions of data or even between different versions of deliverables. So Viva Instrumentation, this is for the process control folks. Um, Intelligent, it creates loop drawings, terminal reports, basically the cable schedules there once we've identified what equipment's required. The instrument index, and you'll see how this application consumes data that has originated on the PNID, and we're going to basically on the PNID we're going to change a control valve size, and we're going to change an instrument loop name, and you're going to see how all that cascades down and is consumed by the process controls engineer, and how that data is updated. But again, same thing, we've got the same concept of data sheets, that the information can be entered into the data sheet or into the grid, and you're going to see how the two are related. And then we've got the instrument hookups as well. And then with AVEVA Electrical, very much the same as AVEVA Instrumentation. We've got cable block diagrams, single one lines, key one lines, all termination drawings. You've got your cable schedules, the load schedules, so all the horsepower and that's been identified, a process, you can determine that. We've got some basic calculations in there for cable size. So what we can do with electrical is we can actually use that data to go in and route the cable inside the 3D model, and then that length, the linear length of the cable, can then be fed back into AVEVA Electrical, and then they can determine whether the power loss is too great and whether they've got to do some recalculations on the size of the cable. And then lastly but not least, what we've got is we've got our design tool, which is AVEVA E3D. So it's a multidiscipline tool. In this particular case, the view you're seeing there is actually a brownfield environment. So what we've got is we've got the laser scan inside the design tool. We've got the ability to do the design within the existing environment, so we can incorporate the laser. We can automate the production of general deliverables, so piping GA, structural general arrangements, all that good stuff, they can be automated. And then we've got integration with third-party applications like the pipe stress interface for CESA2, structural analysis for STAD, and we can also import files in different formats. An example here is STEP, AP203. And we've also got mobile access through E3D Insight. So basically with a tablet, you can walk through the facility, you can look at the tablet, and you can pass comments back into the project. It doesn't have a full design application on it, but what it does is it allows you to review the model outside in the true facility and then feed comments back into the project so that the designer can read those in the design office. Because what we've got is we've got the capability of global work sharing. Some of the largest projects we've ever done have been in the billions of dollars, and basically what we've got in some cases, it's been across multiple locations. Probably 11 locations is the most that I know of at the moment, where it's been spread across construction, fabrication, and different design locations throughout the world. So I think here is just a quick slide. What we do as the data is entered into the database, it's versioned. So what we can do is between the versions of the data, we can highlight the differences, and you're going to see how we can do that. I'll show you the history in the database. But more importantly, what we can do is we can do what we call a compare and update. So with the compare and update, it identifies to the engineer or designer the data that they're currently using, but it also identifies to them the current values of the data in the source. So it's up to the designer or engineer to sort of look at that data and decide whether they want to implement those changes as they go through. And what you'll do is you'll see this a couple of times throughout the presentation, so that you can see how we manage the change and how sort of it impacts and improves the integrity of the data, and obviously the quality of the deliverables that are produced at the end. And this is across the complete suite of applications that we've got. So what we'll do is we will go on to the presentation. So what I've got here is, this is my engineering application. What we've got here is we've got basically an equipment list. This looks like our Excel. It is not Excel. What it does is it sits on top of our database. So what we're doing is we're going to be entering the data, and it's going to be going into the database. Now in this particular case, what we'll do is we'll assume the object that I'm creating has come from the process simulation. We do have integration with process simulation, but we're not going to be talking about that on this on this webinar. And what we'll do is we'll just go through the work process. So what I can do here is I'll come through and I'll create a new object, and we'll create the name. So I'll pick P, say 1501, and this is going to be the standby pump for P1501A. So say B. And what we've got here, it's entered into the database there. And again, we've got some basic tools very similar to Excel where we can fill the data down. Now, the nice thing here is what we can do is we can actually link the two objects. In this particular case, I haven't linked them, but if I wanted to link them, what would happen is there would be specific attributes on these two objects that will be linked. So if in this case they're both main pumps, or even if they're a main pump and a standby, if you enter the design condition or engineering conditions, pressure, temperature, etc., and they're common between the two pumps, if the two pumps are linked, every time you modify the pressure, temperature, and what other attributes that you've linked, it will be updated on the standby pump. So it's up to you. This is fully configurable, so it's up to you as the customer to decide how you want it linked. And basically then what will happen is you're only maintaining the data on one pump, and you're confident that the data on the second pump is the same. If you want to unlink them, it basically the unlink option up here will become active, the link option will become inactive, and basically if you wanted to, you can unlink them as well. But what I'm going to do is I'm just going to quickly create a data sheet here. So I'm going to come here and create a new data sheet. Only the class types that are specific to pumps are displayed. So what I'm going to do is I'm going to create a data sheet. So this data sheet's come up, and what we've got now, this data sheet sits inside our database. So let's just scroll it across a little bit. So what we did is we entered the information on the grid here. So what I'm going to do is I'm basically going to change the information in the data sheet. So I'm going to change that to standby. And if we look here, you can see that the information in the grid has changed as well. So what that's telling me is that's changed the value in the database. And then what we can do is if we wanted to change indoors to outdoors, you'll notice that the indoors to outdoors changes there as well. So what we've got is we're always reading a common source of data. So no matter where I enter the information, it's always going to be consistent across the deliverables. We can also add a picture. So if we wanted to add an image, I've got my pump sketch there, so I can add an image. So what we've got is we've got the ability to add pump sketches as well. So a lot of process engineers are very comfortable in entering the data in through a spreadsheet. So what they can do is they can go into the spreadsheet, they can enter their data and be confident that what's going into the database is actually going to be what's displayed in the grid as well. Okay, and what we can do is we can go through versioning and revisioning. Sorry, turn my email off. Didn't expect that. So let's just turn that off. There we go, it's gone. So what we've got is we've got my data sheet, and what we can do is we can take this through different versions. So what I'm going to do here is I'm just going to talk about the ability to do status control. So what you've got is across all elements, all deliverables, all objects, you've got the ability to apply a status. Okay, these statuses are fully configurable by you, the customer, and they can be different by object types or even by discipline. So what you've got in this particular case, this status definition is specific to the process discipline, and it's very specific to the pump that's in question here. And what I can do is I can take this pump up through different levels of status. Okay, whoops, that's a bad one. So let's take the pump I've just created. Let's take it up through different levels of status. So what I can do is I can promote it to working, and then what I can do is I can promote it to in check as well. Now, as we promote it, what we can do is we can remove privileges. And what I mean by that is that if we've got a junior engineer, junior designer that's entering the data, and we've got a more senior person that's required to check it, as we promote it to in check, what it can do is it can remove the privileges for the junior designer, so the junior designer can no longer change the values on that object. If they wanted to change them, or if there was a requirement for them to change, then what would have to happen is this would have to go back into a working state. So you demote it so that then it gives the privileges back to the respective engineers so they can modify what they need. What we've also got is if we go through the data sheet here, I'll just go bring up my document list. So we go to my documents, go to my data sheets, and I say open. So the data sheet that we just created was this pump P1501B. So what I want to do is I want to take that up through the different levels of status as well. I'm just going to, oops, I should shut it first. Just take it up through the status, and we'll check it to promote, and we'll apply. toolkit, take it to incheck and apply. And then what we'll do is we'll put it into approved and apply. So it's not just updating the datasheet. So now if I go back to the equipment datasheet for that particular object and I say open datasheet, if I go to try and change anything on that datasheet now, it won't let me. It's basically locked. And you can see here that what it's done is it's been issued revision 1, today's date, and it's been issued by me. If I want to go and modify that datasheet, what I have to do is I have to go back and put it into a working state. So we'll put it into a working state. So I'll hit apply, say OK, just shut that, and open it again. And what we will see, go on to this, you now will see at the top that it's 1 star, but more importantly, if we come down the bottom, you'll notice that it's put it as 1 star in the revision box. This is now the working revision for revision 2. So once we go back up through the different levels of status, what it will do is that will change to do it. It'll be the date, the user, etc. And then it'll go into another lock version at revision 2. So that's the way sort of we control what's going on in the data sheet as well. And the reason we can do this is if we look at the history in the database, so we look at the history of the object, you can see here that Richard started this this project, or the work on this project, back in 2013, and you can see in recent times that I've actually taken it over and I've made modifications in 2014, 15 and 16. So what we do is we actually store all the revisions to the attribute, so we know what the value was on an attribute at a particular time. So what that allows us to do is it allows us to compare versions of data and then be able to make the conscious changes to or update the design as required. So now that we've created that object, I haven't put any design conditions on, and you'll see that when I go to the P&ID, but for the purpose of the presentation, we're really only showing how we manage data. So if I go into AVEVA P&ID, like I said, this is using an AutoCAD canvas. There we go. So what we've got here down the bottom, we've got a list of all the equipment that is available to place on the P&ID. So I just need to refresh this grid so that we see P1501B, and it'll be identified as new. So if you look at this grid here, you can see that we've got the existing tags, and in some cases they're saying linked with differences, so it's showing me the number of differences, and in this case it's design temperature and pressure. But more importantly, what I'm interested in is P1501B. P1501B is what we've just created, so P1501B is what I'm going to start using on the P&ID. So I need to publish it, and I need to make it available for P&ID drafting. So we'll just say update the database. And if I come down here, if we look down here, you can see in my P&ID Database Explorer, I've got unassigned and I've got assigned items. So if we look here underneath unassigned equipment, if we look underneath unassigned equipment, okay, so if we look underneath here under unassigned equipment, what we can see is we can see that we've got an object, and that basic object is P1501B. So what we're going to do is we're going to do a little bit of drafting here now, and we're going to use some of that information that we've put into the engineering list to be able to develop P&ID. So what we'll do is we'll say insert. What we want to do is we want to pick a pump, so we'll go to the pump symbols. So we'll pick the pump symbol, say OK, and we'll just place it, and I've already got my tag. Okay. So what I want to do now is I just want to add some symbols. Wait for it to catch up. It's catching up. Okay. So we'll go to the symbols. The first thing I want to do is I want to put on a block. So this is for the equipment condition. So if I just come here, say insert, attach it to the tag, identify the piece of equipment, and you can see there now that what I've got is it's giving me the product feed pump standby. It's all the information that I entered into the engineering application. So if I'd entered the design temperature and pressures, they would have been displayed here as well as they are on P1501. Okay, what we'll do is we'll add some nozzles. So we'll come down, add some nozzles, And what I've got is I've got my auto naming set up, so it automatically names it. Place another nozzle, make it N2. All right, so this is configurable. You'll see that when I come to do the line, I haven't got it set up for auto naming, so you'll see me enter data. So what we'll do is we'll come along, we'll quickly draw the P&ID. So you'll notice that I didn't put any nozzle sizes on the nozzles. What we're going to do is we're going to inherit the nozzle sizes from this drum. The nozzle size is set on this drum, so what we'll do is we'll connect the nozzle to the drum. We'll basically come down. Let's zoom in a little bit. Just come on, connect to that nozzle. Just escape. So here it knows the size. It's inherited the size from the nozzle on the drum. I want to pick a fluid service in this particular case. I want fluid service B. I want to give it a number. So that will be number 8. And I want to give it a pipe spec because these are spec-driven P&IDs. They don't have to be spec-driven, but for the purpose of this presentation, I've done that so we can see how we use that information to go through into the design. So I'll say OK, and I will place the tag drawing. Okay. What I want to do is I want to pipe up the suction to the standby pump. So we'll just pick it, place it, and we want to inherit the properties of the line that it's connecting to. And we'll just cancel that. And then we'll place a couple of valves on here as well. So we come in and we'll put a couple of block valves in. Insert. Again, I've got it set up to give me size and a unique tag. And again here, size and a unique tag. Okay. Then what I'll do is I'm just going to finish it off by connecting to the discharge side of the pump. And what we'll do is we'll just come up here, we'll connect it to this line, inherit properties of this line, cancel it so it uses the same line number. And then what we'll do is we'll just enter a block valve and a check valve. So here again, tag and size. And then what I want is I just want a check valve. So where's my check valve? So, and we'll put my check valve on here as well. Okay, so we'll say okay. Now we're going to do some changes, so you can see how not only do we manage have new items created, we're also going to manage change here. So what I've got is I've got this instrument loop 140. So what I'm going to do here is I'm going to change the instrument loop number to 114. So the properties would change that to 114. And you can see that everything in that loop now has changed to 114. But more importantly, what we're going to do is we're going to change the size of that reducer. So we're going to change it to 1 inch. And if you watch, the size on the control valve and the downstream reducer will change as well. So what we've got is we've basically changed the control valve size now that now affects the process control discipline. And we've also changed the loop, so that could affect the process control discipline as well. What we'll do is we will save all this data to the database. There you go. I've got my progress bar down the bottom. So it's what it's doing. It's doing two things here. It's saving the information to the database, but it's creating a published P&ID that we can view within all the applications, and we're going to use that for various things as we go through the rest of the presentation. So once that's finished, we'll go back into the engineering application. So it's finished. So we'll go back into the engineering application. And this is where we do our compare and update. So the compare and update is basically what I've got here is this is the source of the data. This is the data that I'm currently using. Now the source of the data has changed. So what it's going to do to me, it's going to identify that there's differences between the source and the current versions of the data that I'm currently using. So what we'll do is we'll do a compare and update. We'll open that. We say we want to look at the schematics of the P&ID, and we want equipment. So what you can see is it's matched everything, so it sees everything apart from the nozzle. We won't worry about the nozzles for this, but we can see that there's some basic changes. So if we look at the attribute tab, we can come here and we can see that what we've got as we scroll down, that basically there's a value for the P&ID number in the schematics database, but there's no value for the P&ID number in this column here. So what we can do is we can accept all the differences. can update the database. So if we just move that out of the way, we can update the database. So what you see there now is you can see that because the system has actually changed it, it highlights it in green to me, so I can visually see what's changed in the grid as well. What we'll do is we'll do the same thing for the line list, because what we did is we created that new line going into the suction side of the pumps. So we'll pick the lines, and we'll only focus on the one line, which is the one I created. So we'll pick B8, and you can see there at the bottom, it identifies to me it's not matched, and it gives me it in a red color. So we'll say accept, we'll say update the database, and we'll say update. And you can see there what it's done is it's given me the new line number, the size, the system, but more importantly, it's given me the from and tos as well. The reason it's not showing me any of this information is dynamically coming from the 3D model. And because this line doesn't exist in the 3D model currently, we don't get the data. As soon as we enter the routing of the line in the 3D model, this will populate. If we come to our instrument loops, what we've got, we can see there the instrument loop 140. We know we changed it to 114. So what we'll do is pick loops, and we can see down here that we've got a change. So we've got 114, so we'll update database. And you can now see that it's changed to 114. But more importantly, what we've got is, let's take the filter off of that and change it to 140. Oh, what did I do there? Let's clear the filter totally. There you go. So I changed it to 10. So these are the instruments that were affected by the instrument loop change, but we've also got the size as 1 inch. Again, what we'll do is we'll come into instruments. We'll only focus on the 114s. I know there's a change there. Update the database. So we can now see that it's updated the tag numbers based on the loop name change, and it's also given me the type of element that's been used on the PNID, and also the fact that it's on this particular PNID as well. And then we want to do the inline instruments, because those were offline instruments, so we'll pick that. And in this case, what it will do is, if you watch, we've currently got 1.5 inches there. If I update my database, what we've got, it's changed it to 25. So now what we're going to do is we can make that available to the process controls engineer. But before we do, we've got a number of other things that we can do here. So from an engineering standpoint, from a mechanical process engineer, anybody that's accessing these applications, what they can do is, if I go to a particular object, so we go to the pump that's there, and I say view selected item on diagram, what it does is it brings up the published PNID for me. And as I move about the grid, it will change the current focus. So it's always on the current element. And we can do that both in the grid, and we can do it both inside the PNID as well. So if I go to this pump, you can see that what it's done is it's gone to the grid as well. We can also view this on the 3D model. So if we go to 3D, we've got a viewer into the 3D model. So let's just open up change the clip planes. I need to change those clip planes so we can see what's going on. Oops, went the wrong way. Let's go the right way. Just quickly drag them around. Should see something start to appear. Let's try this one. Let's try P50. Set. So we'll set that east. There you go. Whoops, sorry. So you can see that what we've got is we can start viewing the 3D model, but for some reason it's reset it. There we go. All right, it seems to be resetting it. But what we can do is we can view the object in the 3D model. We can view it on the PNID as well. The other thing we can do is, if we wanted to, is we could do we can look at the differences between the different versions of the PNID. So the current version is today's date. That's what we've done. So we'll set that as the base version. And then what we'll do is we'll just pick something in the past, set that as my target, and we say OK. And what it does is it highlights the differences between the two. And basically between the two versions, I've added a lot. So you can see that it's basically red and green. But what you'll have is, if there was basically differences, So the date the actual object existed and there was a change on that particular object, it would show it as yellow. So what we've got is not only can we just compare the data in the grid, but we can check the data or compare the data across different versions of the deliverables as well. And we can do the same thing with the data sheets. So we'll close that window, we'll do a save work, and we will go into our instrumentation. That one. Again, the same thing. This is where the process control engineer is going to be working. So if we look here, we can see that the control valve FCV 140 is actually 1.5 inches. So we need to go and get that data. So we connect to the PNID. So we'll just enter that one, wrong one. Connect. So this is going to go away and look at the source of the data. So we'll tell it what we want to look at. For the purpose of the presentation, I won't go to the loops. We're interested in the instruments. So what we'll do is we'll say refresh groups, import data. So what that's doing now is that's comparing what I've currently got available to me as an instrument engineer and basically what it is that's been changed by the process engineer. So once it's done, we'll see a similar table. So you can see here that we've got FCV 114 and FE 114. So there's two changes. Or a number of changes. So FCV 114 is basically there's a tag number change and basically a size change, and FE 114 has got a tag number change. So what we'll do is we'll just accept those and we'll update the database. And we'll say close that. So I'll close in a minute. So now if we look at it, we know we didn't change the loop number and we could do the same thing as we did before. But if we look at it, we've seen that the tag number for the control valve has changed. But more importantly, the important thing is change size as well. So now the engineer can go in, they can go and create their data sheet. So what we've got is we've got a number of templates. So we'll call it FCV 114 data sheet. Say next. And what we'll do is we'll just say apply. And okay, so we can enter contract number, requisition number, and things like that if we know them. Say okay. So we come to open it. This is my data sheet. So if we know that we've got a valve that's common, what we can do is we can copy the data. So in this particular case, we've got FCV 220. So we'll say that most of the conditions on this are the same. We can select the fields that we want. So I'll accept all in this particular case, and I will do a save. So you can see here that what we've got is we've got all the information come across, and if any of the fields are in green or they're in grey, that means that's been set by the process group, and therefore it can't be changed. So there's information on a data sheet for a control valve that's basically driven by process, and then obviously there's a lot of information on there that's driven by the process controls engineer as well. So we'll save the changes. Again, we've got the same revision control around the data sheet. But I think the thing that we're showing you here is we've only entered the data once. So we've done a change, we've only done it once. What we're not doing is we're not opening up different documents to look at what the source of the information is and transposing data between documents. That's all gone. What we're doing is we're showing how the data is consumed and controlled by the discipline engineer that's consuming it. And then they've got the confidence that the data, you've got the integrity with the data. What we'll do is we'll just quickly go into the wiring manager, create a quick cable. So what we'll do on this cable block diagram, we'll create a cable block diagram here. So I want to go to new. So I'll just call it CBD-01. And on that, I'll just put a few cables so that we can see what's going on. So if I come to my equipment view, we go to tank farm, field devices, junction boxes. No, it's the junction boxes. It's this one I want. So if I just drag and drop, I've already got a cable associated with it. But what I can do is I can add additional cables to this. So what I can do is I can assign. What we're looking for is we're looking for anything that contains 114. So these, oops, yeah, those are the two that I want. So let's just pick those. And what we can do is if we look here, we've got different wiring rules. So you can see that we've got different wiring rules based on what you require. So for an instrument, they just go, and electrical designer, they just go and pick the different wiring rules that they require. And we can say, okay, so we'll say create. Oops, sorry, need to set the wiring rule. Say okay, and we'll say create. All right, so there's an error there with the terminations. I'm not going to go into the termination block, but you can see now that what I've got is I've got the cables running from the control valve to the junction box and running from the flow element to the junction box as well. So what we can do is we can start using a lot of this information inside the 3D. Go into the 3D model. 3D model. So what we've got here, the two pumps that we were looking at on the P&ID are these two pumps here. The drum that we were working with is this drum here. So what we'll do is we go into the piping application and we put it into integrator mode. Now the reason it puts it into grayscale for integrate mode, because if we're doing a check against the model, what it will do is it will color the P&ID and the model the same color. So you can relate the P&ID to the 3D model or the 3D model to the P&ID. So what we want to do is we want to open up the diagram. Sorry, I just need to do a refresh here. Open up the diagram. What we want to do is pick up diagram number 4. And this is the published P&ID again. So we just zoom in, you can see that we've got the P&ID. And what we want to do is we're interested in that line there. So in this particular case, I could do a compare, but it's already come back. You can just see the side of it. It's in red, so it tells me or informs me visually that it hasn't found that line in the model. But more also, the build pipe is active as well. So that visually tells me that there's no pipe in the model. If the pipe was in the model, this would come up and have done the compare. You know, I'd like to see green. Green is perfect, but it would be a mixture of green, yellow, and maybe some red if there were some components missing. But what we'll do is we'll build the pipe. Okay, so it's done the first routing of the pipe. I'm not going to say it's the perfect routing, but what it's done is it's given us a first pass. So in this particular case, it's it's blocking access to the front of the pump and things like that. So we'll probably want to reroute it. But if I was to come along now and generate a pipe isometric, what I've got is I've got a fully dimensioned pipe isometric. Again, this is fully configurable, but you can see up here I've got my shop components, I've got my field components, I've got all my bolts calculated, and this isometric was generated as you saw in real time, and the isometric takes about 2 to 3 seconds to generate, and we can be confident that the information on this isometric is what is reflected on the P&ID, and also any of the engineering conditions, if we've shown them, we haven't shown them in this particular case, but if any of the engineering conditions for design temperature, test pressure, test medium, etc. were shown on this isometric, we could be confident that they agreed with the respective list or information from the process department. What we can also do is if we just back a little bit here, if we go to manage, and again we're going to do a compare and update. So I want to go to instrumentation, I want to go and get my cable, I want to log in, project. So what it's done is it's found 2 cables. Those are the 2 cables that we were working with. So if I update the database with those, so we want to put them in cables, that's where I want to go, so say okay. In this particular case, if I'd configured it so that it went into the parent hierarchy, I've missed that. So we just do an update. So it's created those. So if I come over here and I look at my model, what we'll see is if I come down to my INS cables, you will see that it's created 2 cables. And I can tell that they're being just created because they're bold, and that means that I've got them claimed. So what we can do is we can go into the cabling system, and then we can go to cable data, And then what we can do is we can look and see we've got, and if possible, what we want to do is we want to automatically route them from through here. I know it won't do it because it's such a short length. So what I'll do is I will actually go into the modify cable. Must be at a cable or below. Sorry. So if I go to the cable, down here I've got the ability to define a route. So what we'll do is we'll just say head free route, and you'll notice there what it's done. You can just see it. You can just see that it's put a cable in the model. So what it's done is it's run the cable from the control valve to the junction box. Now what we can do is we can take that information back into instrumentation with the actual length, or even if it's electrical, and they can redo their calculations based on the length. So I'm hoping from this presentation you've sort of seen the benefits of data centricity, how we manage change across the disciplines, and how the integrity of the data is actually improved. So on that, are there any questions?
Yes, Ian, we had a few questions come in. The first one is, what challenges do you have today in project execution?
Is that for me? Okay, so for the audience out there, what challenges do you have in project execution today? I'm from industry. I know one of my biggest challenges was knowing if I was ever using the latest data. So we were always transposing data between the different design applications and engineering applications, and ultimately we always made mistakes, and it wasn't intentional. And those mistakes in engineering design are relatively, if you look at it, there's ballpark figures for this, but the changes are minimal. The cost is minimal. But once you start going to procuring equipment and bulk materials, the change, if you've got to go and change materials, in some cases they won't accept components back. If you made a mistake on a piece of equipment, it's got to be refabricated, so there's a cost associated with that. But the big cost is in construction. And with this, if you do a change, it impacts schedule. And some of these process facilities go together like a jigsaw puzzle. They've got a coordinated way that they go together, so they've got to be in a particular sequence. If you can't meet that particular sequence, you know, if you've got a vessel that's been affected and you've got to go away and have it refabricated, it affects the installation. It may be that it's got to be put in before a pipe rack. That pipe rack can't go in, so what you've got is it affects the pipes going in the pipe rack, and it has a whole compound effect, and the costs associated with that can be quite considerable. Any more questions?
Oh, it looks like that was it, Ian. Thank you, Ian. Okay, and thank you to everyone who attended. If anyone would like to review any portion of this webinar, a recording will be available on YouTube and our website, california.wonderwork.com, later this afternoon, and you will be receiving a copy of it via email. Thank you again for attending, and have a great weekend.
Cheers, everybody. Bye-bye.